We always have to think about the pros and cons. If you're not old enough to know what that means, basically, when you eat candies, again, you feel good, so you enjoy it. But there is a that's a pro because you say, hey, I like it. But there is a con. Mother will tell you that's not good for you. It's going to make your teeth rot. It's going to cause you health problems, and it's going to make your tummy hurt, and so on. So just like that, everything we do in life can have a pro and a con, an advantage and a disadvantage, a good thing and a bad thing. So we have to discuss that every time we say we'll solve climate problem by having nuclear energy or natural gas and so on and so forth. So here, natural gas and nuclear energy, the pros and cons. Natural gas is a fossil fuel for sure, and it's drilled from deep beneath the earth's surface, just like oil and coal. It supplies about 30% of US energy and emits only about half as much CO2 as coal does. Okay, listen to it carefully. Coal is a fossil fuel and natural gas is a fossil fuel, but natural gas is a cleaner fossil fuel. Thus means that it still emits greenhouse gases, but only about half as much as coal does. Plus coal also has other things like particulate material. When you burn coal, there are particles flying out that are very small and that can get into your lungs and into your blood and into your brain and can cause all kinds of health problems. And small particles of black carbon that also fly out can absorb sunlight and make the climate warmer and so on. But it also produces sulfuric acid, sulfates, which can scatter sunlight. So the point is there are many things happen. It's not just that you are providing jobs to coal miners. Their health is not good if they keep going into coal mines and are not protected, and it can be dangerous as well, and so on and so forth. Okay, but coming back to coal and natural gas emits only about half as much CO2 as coal does, but natural gas is mostly methane. Methane escapes during the drilling operation to get natural gas out of the earth, and it can leak from the pipelines that are transferring the natural gas from the mine, the natural gas drilling site, to wherever in your home. You may be getting gas at the stove and you just turn it on and turn on the spark, and then you get cooking gas, right? This is very comfortable and convenient, but it can leak as well. One removal method known as fracking has been linked to earthquakes. This is a bit of a detail. If you're too young, you don't have to worry about it, but if you're old enough, you may have heard of fracking. Basically, it's called hydraulic fracturing, which is for short called fracking, which means as the oil and gas and coal form in the ocean, how are they forming? Remember, the photosynthetic material, the hydrocarbons and sugar that fall to the ground and get buried in the ocean and so on, or get crushed over time and get converted into fossil fuels. Hence they can be burned to extract the energy, because photosynthesis captured the energy and put it into these materials. And the gas which can flow can go into little nooks and crannies and holes in the rocks and the mud underneath that is compressed and so on, and when you put a pipe and try to take it out, it doesn't easily come out. So human beings got very smart and they said, let's pump some water into these little holes and push that gas out of these tiny holes and cracks and so on. And this is, very expensive to do, plus you are using water that could be used for something else. Water is already in great demand and short supply, and then you are causing little earthquakes and so on and so forth. Somebody is ringing my doorbell. Hold on a second there. Okay, so we are talking about nuclear and natural gas, and we said fracking pushes water into these little holes and tries to push out the gas to, extract every drop of gas that is there because you can sell it and make money. But it's found that it can create seismic activities or little earthquakes. Of course, it contaminates water, groundwater that we talked about, and so on. There hasn't been any big accidents yet, but many people are still continuing with fracking, even though it's considered not safe and probably environmentally not very friendly either. Okay, so nuclear reactors use the elements uranium to produce energy. If you don't know chemistry, don't worry about it. If you're old enough, you know that uranium, basically you have nuclear fission where you split the atoms into neutrons and protons and electrons, and the energy that is holding them together is enormous, and that energy is released, which can be captured to produce electricity and so on. And generally these things don't produce CO2 or greenhouse gases when you're producing the energy, but uranium has to come out of the ground as well. These power plants split the most basic unit of uranium, the atom. If you don't know what that is, don't worry about it. Then they release the energy from the nucleus, which holds the protons and the neutrons together, which is the atom's core. No greenhouse gases are emitted, but the process leaves toxic, poisonous waste and can cause serious health problems and can kill people. And when you mine for uranium, you will be again creating emissions. When you transport uranium from the mining site to the nuclear plant, you will be causing emissions, and you don't get pure uranium out. It's like digging out gold, and the gold has to be processed, and diamond comes out of the ground, but it has to be cut and transported. So everything has emissions, so we have to always worry about these things. So nuclear reactors can also have meltdowns, which means so much energy is produced that you go out of control, with uranium burning through the reactor and releasing harmful radiation into the surrounding areas. What is radiation? You already learned it. We had incoming solar radiation, outgoing thermal radiation, and if you get radiation in the wrong wavelength, we die. Our brain gets damaged, our skin gets damaged, our DNA gets damaged, and so on and so forth. So not every energy is necessarily safe, and people perceive it as a big risk. And now there are smaller nuclear reactors. Usually when you have a nuclear reactor, nuclear power plant, because it is so dangerous, you have miles and miles of empty space around it, and nobody wants to live near it, and so on and so forth. So they will put it far away on some island or so, like the 3 Mile Island accident that the US had, I think, in the 1970s, and so on. So everything we do has to be considered from the beginning to the end. Where does uranium come from? How much emission is involved? What happens when uranium is split? Is it safe? And then what happens to the product that comes out of it? It's called nuclear waste. Just like when you burn wood, for example, it has ash and emissions. When you put gasoline in the car and you drive, it has emissions and produces greenhouse gases. Nuclear power plants burn uranium, split uranium, and produce nuclear waste, which is highly radioactive, which has to be put away somewhere. Again, nobody wants it in their neighborhood, so you go and find a mountain far away and you hide it there and say it is safe and it's buried deep and it will not leak radiation and so on. So for those who are old enough, these are called life cycle analysis, and it's a very good example of how to think about it. Let's say I have a phone here, I just bought the phone. It has many materials that go into making it. It has a battery, it has a chip, and it has a receiver and a speaker and everything. Each material comes from different places, and it is manufactured into different pieces, and the different pieces are transported to some place like Malaysia or China or India, where it gets assembled, and then it gets shipped back to many shops across the world, and I buy it, and then when I use it and I'm not able to use it anymore, I have to get rid of it. So this beginning to end thing is called a life cycle analysis, and we have to understand the emissions throughout, and whether is it completely recyclable, or is it going to end up somewhere in the ground and not ever disappear. So the pros and cons are not just for natural gas and nuclear energy. I'm taking this opportunity to tell you that we have to worry about the pros and cons of everything we do, including solar panels and wind energy, because solar panels need some material to produce them, and then they work for a certain number of years, and then they have to be recycled or taken care of, and same for wind energy, and so on and so forth. So nothing is so simple. That's what we have to remember. So we'll come back and discuss where the nuclear energies are already being produced and used. And there is good news that there are many countries which are investing large amounts of money into implementing or establishing or installing solar panels and windmills on land, offshore, in the ocean, in deserts, and so on, to produce solar energy and nuclear energy and wind energy and hydroelectric energy, which is where you basically build a big dam and hold a lot of water that is coming down the river, and then you release the water into a turbine, and the turbine rotates and produces energy. Again, it's the renewable energy, but again, when you store water behind the dam, you change the fisheries impact on dams. When you put a lot of water behind them for a long time, they can produce methane, and when you collect water behind the dam, it can cover a lot of forests, and people may have to leave because their village is going to be underwater, and so on and so forth. So again, hydroelectric is not always completely safe in that sense for the environment, biodiversity, and so on. Plus, imagine you built a big dam, and then climate change caused the rain to disappear or become much less. Then what happens? Or say it rains a lot and the dam begins to get full and becomes dangerous, and you suddenly release a lot of water, and lot of people down on the other side of the dam get a sudden flood because the dam released a lot of water to save the dam. So all kinds of issues exist. Do I mean you have to get scared? Of course not. These are technologies that work safely when we are careful. So you have to learn about them and learn all the pros and cons about them and make the choices, because you may grow up to build safer nuclear plants, safer dams, and collect water more carefully and reduce CO2 carbon capture, make more efficient solar cells and windmills, and so on and so forth. Lot of nice fun work to do and make money and save humanity. So you must learn as much as you can. Okay, so see you in the next podcast to talk more about renewable energy being used by people. Okay, see you, children.